Just make sure that the Renderman plugin is loaded. You should see Renderman up here on the top of the screen. You also should see a shelf button over here or a shelf for Renderman 22.6. If you don't see that, let me show you how to load the plugin and make sure it is still there. Okay. Actually, does anyone know where plugins are in Maya? Does anyone remember? In preferences. So if I go up to where? Walk me through it.
That's as far as I got.
Okay. Let's go up to Windows, Settings, Preferences, Plugin Manager. And then if we roll down, we can go to, should see one that says Renderman for Maya.py. If you click Loaded, it will load the plugin into Maya. If you click Auto Load, it will automatically load it every time you open up Maya. If for whatever reason Renderman is not showing up, make sure you go in here and turn it on and check here. If it is not showing up in here, it may not be installed properly. So if you need to load it in, you can go into Browse and look for the Renderman to Maya py file, Python file, wherever you may have dropped it. Although it should be installed under the Maya 2018 bin plugins folder. Okie doke. Okay.
Is it under render setup, or is it? Okay, never mind. Sorry. There it is. Sorry.
Okay. All right. Okie doke. All right, let's go ahead and create some objects. I'm going to make, let's make a sphere so we can actually see something. And then I'm going to be using a lot of stuff over here in the Renderman shelf. So I just honestly like to go to the shelf and just grab everything I need off of there. It's just a lot easier. I will be going through the Hypershade, which you guys may have gone through when you were in Intro to Animation, or Intro 3D, I should say. But anyway, this is where I'm going to be spending a lot of time here, so make sure you got that up. So, Renderman basically has control over a few different things. Renderman creates its own lights, it has its own shaders, it has its own volumes, and so if you have ever used any of those, like say Maya lights, Maya shaders, Maya volumes, do be aware that they don't really work with Renderman. So, do you guys remember any of the shaders that are kind of pre-installed with Maya? There's like one, everything.
Maya standard or something?
Maya standard what? Like, do you know what the gray color is called that every?
Lambert.
It's a Lambert. So we have Lamberts, Fongs, blends. Those are standard Maya materials. Those don't really work with Renderman. Okay? So if something is not rendering the proper color, it may be because you don't have a Renderman material on it. Okay? Think of a Renderman material as like a coat of paint. You just may not have the right one. All right? So if I wanted to create a Renderman material, I can go up here, and if I right-click on this little circus ball, I have different ones that I can click from. Now, the standard one that I kind of typically will use is a Pixar Surface shader. This is like your meat and potato shader. This thing can do pretty much everything you can imagine or you would want a standard shader to do. So, if I click it and add it to this object, you'll see that now we have Pixar Surface 1 attached to this sphere. Now, this sphere has, the Pixar Surface has different attributes that if you're used to looking at anything like a Lambert, Fong, or a blend, that may look pretty familiar. You have places to add in color. You have a specular channel where you can make things shiny. So you have a lot of different things that are going to be similar to the other materials. So let's go ahead and maybe kind of render this out and see what it looks like. Now inside of Renderman, we have a couple different places we can get renders from. If we wanted an active render, like one that updates for us all the time, we can turn on the IPR renderer. We can also we can click on this button right here. Now it will load this little window, and then you'll notice that when I rotate, it'll actually will update live right there. So if I go and change my color, let's do pink, it'll update live. Now, if you have a dual screen monitor setup, this is perfect. Frankly, I think if I had to do this split screen, that's kind of a pain in the butt. But you can do it if you need to. But you'll see as I'm moving the monitor around, it is updating the render live. Now, this is great if you have something, you know, low poly without a lot of stuff going on. This is pretty cool. This tends to get kind of heavy when you get, or kind of slow when you have heavier scenes. So just be aware of that. This is not something, in terms of speed, I don't usually use this too much. But it's good if you want to get like a quick look at something simple. All right? Or if you're making like quick changes, like small changes, it'll just automatically update, which is cool. If you want just a normal good render, you can click on the render button right here, and this will give you a preview render. And this will not update as we move around. It'll keep the image right here. You'll see that as we start rendering stuff out, and if I click R, that is the shortcut key for rendering, and it'll just re-render it again. Okay, and then as we add renders here, you'll see we'll get a little catalog of renders that we can flip through. So if you make like a change, you can go back and look at something previous, or maybe get different angles on the same thing, and then kind of load them in as you need it. All right? Okay. All right, so we can do shaders, we can do lights. So let's go ahead and just add in just a normal light. You guys remember any of the Maya lights? Yeah, we get basically like a directional light, we get a spotlight, yeah. So basically these are the same type of lights is what we have here. These are all basically like physical lights. These give us really nice physical properties, so there's like fall off, and we can do things like temperature changes for the light. So let's go ahead and put in a distant light. And I'm actually going to go ahead and turn on the display port renderer. Now this is basically the same thing as the IPR renderer, but it will do it inside of the display port, which is kind of cool. And so you can still move around the viewport however you want. It's just going to update the render in real time.
And this how you turn that on?
It's in the viewport right here. Renderer, Renderman.
Oh, okay, thank you.
Now, the distance light right here does not care about the scale of the light. It does not care about the position of the light. The only thing it cares about is the angle. Because what this is basically creating is sunlight. The sun is, for all intents and purposes, an infinite amount of distance away from us. It's just something that we cannot touch. So at whatever, 93 million miles or whatever it is that we are from the sun, basically the photons that are coming from the sun and illuminating Earth they're not traveling in a perfectly parallel direction, just because that's not possible, but it's parallel enough to where we can mimic that with this distant light. Now, when I'm saying parallel, I'm saying that basically all the light hitting this ball is coming from basically a panel an infinite amount of distance away. So the photons are not moving out at an angle from each other, okay? But we can create that if we need to. So I'm going to go ahead and delete that light, and we can create a disk light. And so this is a light that does have a source, it does have an origin, and so the photons coming out of this light are kind of coming out at a cone, okay? It's basically a spotlight. Now, with all of these lights, these do have similar properties to each other that we can change. They all have an intensity. They have an exposure. We can change the color. And we can also change temperature. We get this back to white. And temperature is really kind of interesting because that gives us kind of overall color change to the image. Now, when I'm talking about temperature with light, does anyone have any idea what I'm talking about? Like, what does temperature even mean? No? Do you guys ever notice when you pick up flash or light bulbs in the store, they may have like a temperature number on there? It doesn't mean that the temperature of the light's going to be, 65,000 degrees, but it may be putting out light that's similar to something that's 65,000 or 6,500 or whatever. So the hotter something gets, it tends to go into the bluer spectrum. The cooler something gets, it tends to go into a redder spectrum. This is, if any of you guys ever take like astronomy classes, you'll learn about that. I always thought that was pretty cool that like it goes blue. You would not expect it to go blue, but it does. So right now it's like a 6,500, that's gonna be like white for us. If I go to 2,400, you'll see it turns red. And then if I go to 8,500, you'll see it gets a little bit bluer. So kind of cool. With some of these lights, we also do have some focusing we can do with it. So if we go down here to like a cone angle, we have this thing we can kind of bring down. You'll see it kind of starts off kind of flat. And then we can focus it in a bit more like a spotlight, like an actual like pen light if we wanted to. So you'll see that we get like a light shape on there, which is kind of neat. And then we can also do a cone softness, which gives us a little bit of a fall off. So usually anytime I'm going to be working with the cone angle, I'm almost always going to be putting a little bit of a softness on there, just because physically there's always going to be some level of gray between like the bright light and the dark area, dark shadowed area. So, all right. We do have rectangle light. Rectangle light is, for all intents and purposes, basically the same thing as the disk light. It's just a rectangle. Okay, so you can use this like as a panel light if you need to. Maybe like, if you're building like a room like in here, you could use like panel or rectangle lights maybe for these light strips.
When you do that, does it make, does the light come out like perpendicular to the rectangle, or does it come out?
I'll show you. I mean, we have the basically the cone angle we can play around with, and so we can make it come out. It's going to come out basically as like a flat plane without messing with the cone angle. Once we start closing that in, then you'll see it kind of start to lock in a little bit. So like with this one, let me give it a quick Pixar surface. So you'll see it's like pretty diffused right there. It's kind of just going everywhere. Let's go ahead and bring up the intensity a bit. Then you can bring down that cone angle if you wanted to kind of keep it maybe a little bit more, a little more limited. Or maybe like with here, like if you look at the light itself, like obviously it's coming out at one specific angle, but it's kind of diffused with that piece of plastic that's over it. So maybe you'll just kind of keep it mostly flat, then kind of mess with the cone softness a bit. Something like that. So, all right. What else? Sphere light. This is kind of like a little point light. It's basically like a little candle light. Like that's essentially what it is. Just like a little candle. You'll notice that as it shrinks, it gets dimmer. As it grows, it gets a little bit brighter. If it cuts through anything, you'll see these little black dots. I mean, that looks kind of cool, actually. It's like a black hole or something. So, anyway, that thing basically works the same way as the other ones. But definitely scale. It's an omnidirectional light, so light's going to come in all directions for it. But you can still mess with the intensity, exposure, color, all sorts of stuff with it. All right. Cylinder light. So this one is kind of interesting because it works basically as a shape, or as a kind of like a volumetric shape. So you'll notice that like stuff inside of it's not illuminated, but it's emitting light directly outside of it. So if we go up and change intensity a little bit, this might be good if you want to make like a lantern or something like that. Really easy. You can just kind of like stick this on top of like a lantern object. And that could give you something kind of interesting to look at. So there it is with the visibility turned on. Turned off if you need it. All right. we have what's called a dome light. And so this is essentially a sphere that emits light inside. It's pretty good for giving you like really even lighting all around. It's kind of terrible because it essentially flattens out your image. You have no shadows, you have no depth. It's just, I don't use these a whole lot unless I need kind of like a little bit extra all around ambient lighting. So these are cool, but they're kind of annoying a little bit. So I might pair it with like a directional light. If I kind of want everything to get a little illuminated and get a little bit of that extra bounce lighting that a distance light just isn't going to give you, at least in the way that you may want it. And then just like turn down the dome light quite a bit, so you still get a little bit of that bouncing light action, the indirect lighting right back here. So this is at least a little bit illuminated, but you know, if you didn't have this, it essentially would just be a heck of a lot darker. Now the nice thing with dome lights is right here you have an option for color map. So this is actually really kind of neat though. We have this thing called an Hdri, which is a high dynamic range image. Has anyone heard of that before? What is it?
From what I understand, it's like you can take like a high resolution image, say like of the desert, put it on the dome light, and it'll give you like the, I don't know how to phrase it, but like a similar like
You're on the right path.
color scheme. I don't know, but like
Mhm.
light scheme as the image does.
Yes.
You're seeing.
Exactly. So an HDRI, so in film, what they will do is, let's say if we have C3PO. What color is C3PO? Gold. Gold is super shiny, right? He's like super freaking reflective. Yes, everything I can, I'm going to switch over to Star Wars, so just, I'm sorry. So anyway, in those films, what will happen is if they have a non-guy, if they don't have a guy in a suit, if they need to like put like a digital C3PO in there, one of the problems is that it is really, really hard to get the Tatooine desert on a digital C3PO. They can't just click a button and go, okay, we have reflections now. You got to have those reflections coming from somewhere. So what will happen is you'll have a guy go out there with a chrome ball, and they will take a series of images of this chrome ball, and they will stitch those images from the chrome ball together to create a warped color map that they can then put onto a dome light. And the dome light is going to give us, with that map, is going to give us accurate lighting for that environment. Now, when you put in your C3PO, he will get reflections that are accurate to the Tatooine desert, which is kind of cool. So that's how they add that in there. So the dome light is useful for that. It's good for accurate lighting. So if you have like a specific lighting setup for like a scene with like the sun is like at a 2 o'clock position, then you can get that because the pixels of that image are going to be brighter in that area. And so depending on how bright those pixels are, it'll actually will emit more light from the dome light. So anyway, we'll get over to that once we start talking about texture mapping. But that's something that you would use a dome light for. All right. Let's get rid of the dome light. Let's get rid of that. Let's go to environmental daylight. All right, this is really useful too. This is basically a daylight system that is just a one-click operation inside of Renderman. This is really cool because it comes with like a little compass on it. And so if you have like a very specific north direction in your scene, you can just align it to wherever it needs to go. But the cool thing is the light changes based on the time of day. and you have a sky with haze. So, you know, if you're, I guess if you're in downtown Houston at 4 p.m., you know, this might be what you see. But you can change all of this if you need to. So we have, you know, things like intensity. Obviously, we can change that however we need to. We can change the haziness. Australia.
No, it needs to be more on fire.
Not burning Australia, but still smoky. We also do have a sun shape right here that we can change. You'll notice that it's, you know, it's pretty close to the right direction, which is pretty cool. You'll notice that your shadows change based on the haziness. So little haze, we get pretty decent shadowing right here. A lot of haze, we don't really get that many shadows. It's pretty diffused. You can change the sky tint if you want to. Let's go with a violet sky. Maybe a green sky. Let's go back to white. You can change the sun tint if you need to. Maybe we are on Krypton. I'm sorry. Maybe we're on Krypton. There you go. So there's your sun. You can also change, I think this is actually really neat. If you wanted to know like what the sun, where the sun would specifically be, let's say if in your story you're doing April, the date specifically is April 1st. April 1st is, no, when's Groundhog's Day?
Isn't it the second?
February 2nd.
February 2nd? Okay. So, February 2nd, 2020 at 2 o'clock in the morning. No, let's do 8 in the morning, -8 time zone, and if you have like a specific latitude, longitude, you could put that in. So you can make like a very specific lighting setup if you needed to do that. So I think that's pretty cool. Now this would be really useful because if you're doing something like further north or maybe on the equator, light angles do change pretty drastically. Like the position of the sun in the sky in, you know, October in upper Alaska is going to be really, really low. December is going to be non-existent. But, you know, if you need to do that, you can do that, which I think that's pretty cool. So, all right. Let's keep that on for a minute. And let's talk about the shaders. Actually, any questions so far? Yes.
Is there a way to do like shape lights with Renderman?
Say what?
Shape lights, like actual objects that are
Actually, you know what? Yes, there is. Let's say you wanted to make a lightsaber, because who doesn't? So I'm going to go ahead and go right here. You see this little sphere with a grid on it. So this is actually an object light. And so what I can do is apply that to an object. And that object now becomes a real light. There it is. You can obviously change the intensity however you want. You can change the color. And then if you need to, you can load in a texture, whatever you want in there. So if you want to make a lightsaber, that's how you do it. Or a neon light. That works too. All right. Any questions on lighting before yes?
So when you were talking about CP3 and the chrome effect,
Yeah.
is that the same way you could do with like lighting water and glass?
If you had CG water that you needed to put into like a real life shot, then yeah. Yeah.
What about fire?
That's like simulation, so we're not really covering that.
It's not like, here's a firelight.
No. Okay. Let me go over. Let's talk about materials again. Let's do. Okay, let's give it. All right, let's go with a nice blue. All right, so under diffuse, obviously we can do any of the colors we want. You'll notice that under a lot of these channels, so like diffuse, primary specular, rough specular, you may see some of the same things just being listed in different places. Make sure that depending on what you want to affect, you're looking at the correct section of the shader, okay? So you may see like a color here under specular, but you also will see color here. These are not the same things, okay? So primary specular, that's gonna be affecting basically the shininess or the reflectivity of the object. So that's gonna be different than diffuse, which is just the flat color, all right? So if I do primary specular here, what I can do is go under face color, and if I bring that up, you'll see that now the object looks a little shiny. It's got a little specular highlight, okay? We can change the face color if we wanted to, and change it to, you know, pink, green, whatever you need to. You can also change the edge color, so the little edge around the specular highlight will actually change. And then we can also change the roughness. And that's going to basically change the sharpness of whatever the highlight is and the size of the highlight. So something that's going to be a little bit more matte is going to break up a specular highlight more than something that is like a little like chrome ball. Okay, so like a brush steel versus stainless steel or a chrome, they're going to have different specular properties. All right, this is going to be something you're going to want to really kind of pay attention to when you're making materials, is how specular an object is. So it's kind of a big deal when it comes to materials. So something like glass, depending on what the glass is going to be used for, would have different specular properties. If it was a mirror, how specular would it be? Or how rough would that specular highlight be?
No roughness.
It'd be pretty low, right? But if it was like frosted, what would it be? It'd be higher, exactly. So actually, let me go ahead and make a copy of this. And let's do environmental daylight. All right, so let's go back to here. I'm going to reset this a little bit. So I'm going to bring up the face color all the way up to white. If I go all the way down to roughness on 0, you'll see that it basically turns chrome. So we get pretty decent reflections. As the roughness is brought up, we do still have a reflection. We do have a little bit of that reflective shape here, but it's just not as visible until finally we'll have nothing at all. It's going to have a highlight from the environment, but we just won't be able to see any detail. Okay? Any questions on that so far? No? Okay. All right. Rough Specular is another specular channel. Essentially, the controls are identical to primary specular, but this is a secondary specular channel that we can add other stuff into. So let's say if something is maybe like a partially partially matte ball, like steel ball or something like that. It's a little brushed, but it's wet. So there's going to be 2 layers of specularity on it. One is going to be the steel. The second may be like the water that's on the surface, or maybe it's like shellacked where it has like a coating of polyurethane on it. That's going to add a secondary level. So like your table, you put polyurethane on it, right? So the wood does not have a reflective quality to it, right? But I would assume that if you put some of that polyurethane on it, it probably has some reflective qualities now. So that's what basically adding these different levels or these different layers of specular highlighting allows you to do, is you can add in multiple stuff.
So if you're trying to make shiny wood, you would just put like a rough specular over it?
Well, you would do a rough, well, you could do a primary and a rough. So when we get into texture mapping, we're going to talk about everything is specular in some way, shape, or form. You are specular. I'm specular. We all have oils on our face that makes light kind of bounce off of us in certain directions. Now, we would have like a map that would have areas of the face that would maybe be a little bit more specular than others. So let's say if I was, you know, a 14-year-old teenager, you know, going hard through puberty, you know, you're going to have basically a really glossy face, right? Yeah? Because, you know, you got a lot of oil at that age. And so you could add in like specific maps that would you know, work with that. Does that make sense? Okay. All right. We have another specular channel called Clear Coat. This one's really meant for like a polyurethane coat or like a shellac or something like that, just something that kind of sits on top of the surface, but it's basically the same thing as the others. Like it adds another layer on there. These are all, these seem really redundant, but again, this is for like details. So specular highlights are really, really important if we're going to bring out things like scales, skin pores, scars, bumps, anything that gives us detail on the surface of an object. That's specular highlighting is going to allow us to do that. Okay. But probably at this stage for this project, you're probably not going to be working with clear coat. It's probably going to be more of like just these two. All right. Iridescence. Let's turn this off. Turn that off. This is kind of like specular, but allows us to kind of bring in color into it. Basically, it's just iridescent. It's like, you know, one of those like Japanese beetles, you know, you see with like the really colorful backs. Or if you ever at a gas station, he's like a little puddle of gasoline, kind of reflects the colors. That's essentially what it allows you to do. You can change and add that into here. So you can go in and change the colors. Let's do, what do I got? Red and blue. Let's change it to yellow, teal. So you can customize that however you want. And then bring up and down the roughness however you need. Fuzz. This is kind of like felt. Like it sometimes got like a little bit of like a felted quality to it. Kind of like the surface of a pool table. So this one's going to be pretty subtle, and it's going to be kind of hard to see in this low quality render. But it does give you like just a little bit of a color shift. Kind of when you get like a little bit further down here, you'll see like some of that brown coming in right there. Yeah, there you go. See that? I think this could be probably used in like atmospherics. This kind of reminds me of like, you ever see like any pictures of like Venus or Uranus or Neptune? Kind of has like that same kind of quality to it. I think it's kind of neat. All right, subsurface. Okay, this is how you make skin. Skin, rubber, anything that has a translucent quality to it, it's going to be under subsurface, okay? Subsurface is basically whenever light hits a surface, goes through that material, and then bounces around inside, and then comes back out, all right? Subsurface is why when you hold your hand up to a flashlight, it turns red, okay? It's because light is moving through that object. So if I go and turn on subsurface, you'll see these immediately get brighter because the light from the sun is hitting this and illuminating it. You'll see that we have a mean free path color. That's basically going to be the color that we see when the light illuminates the object. So you'll see it's a little bit whiter on the light facing angle than on the back side of that object. So if I go and take this guy, and it actually does depend on the distance of the object. So you'll see a little bit more illumination on objects that are smaller, that have less distance between them. Yeah, so it'll be, actually let me go ahead and delete this. And let me get a distant light. See that red right there? Does it show up on the screen? Yeah, kind of. So basically, depending on the scale of the object, that's going to affect how much light will transmit through it, okay? Because you'll see that the light's coming through here, but if we look at like this object, we don't see that same highlighting. There's a little bit of it, but it's just not as much, okay? Yeah, it's just doing a lot fewer samples, just trying to get you the impression of what the image looks like. So if I let it sit here, it would keep trying to refine itself. But since this is a IPR renderer, it's doing it actively, it's not going to give us a high quality image. If you wanted to see what this looks like with more quality, we could go and do a preview render. And you'll see it actually will go through and render the whole thing. And eventually we'll refine out all that static. It also depends a lot on your render settings, so like how high your sampling is and how big the resolution of the image is. So you can already see like that's higher quality than what we have here. All right. Mean free path distance. This is kind of controlling how far the light will go through. Shorter numbers, it won't go through as far. Higher numbers, the light will go through further. So you can change it however you want. Color is going to be the light facing color. So if I change this to like a green, it's going to change the overall color of the object a little bit. So a lot of times when I'm doing skin, I will have a color map for my character that's going to go in my diffuse, but then also I'm going to be pumping that same color map into my subsurface. If you want to get super technical about it, you could also do like subsurface maps. Back when I used a render engine called Mental Ray, back in the day. Huh? No. I mean, it was on 3ds Max, but it was like the one that came packaged with Maya for like years and years and years, and then NVIDIA was like, I don't want to do this anymore. So anyway, they had like all these different channels like you could put in like different like color maps with for their subsurface, and so they had ones for like subdermal, epidermis, subcutaneous, like all these different ones. So you could literally make like a translucent frog that had like organs and like muscle tissue like underneath the skin. It was pretty cool and involved, but it was also really like complex and confusing for a lot of people. But this is nice. This simplifies things quite a bit. So anyway, let me move this over. We'll go ahead and take that off. We do have a single scatter in here. This is basically a really simplified version of Subsurface. Actually, I did forget one thing. Subsurface model right here. If you click, you'll see all these different names. These are all different mathematic processes that deal with how the light is going to transfer through the object. I don't know the math behind any of these. I just know that I click them and it gives me different things. So I tend to go with a couple of them. Jensen Dipole and Dion are kind of the two that I play around with. Dion I feel is pretty decent for skin, but these all have different specific uses. I highly suggest you play with them and see what they give you. Okay? You're a kid, this is your sandbox. Don't sit there and just do nothing. Because like if I do Dion, you'll see it, well, you're not going to see anything because I didn't do game, but it'll give you a little bit of a different effect. So anyway, back to single scatter. This is going to be kind of like Subsurface, but it's going to be really simplified. It's just going to give you like one color, and it's going to be super easy. So this might be good for like rubber, like elastic latex or something like that. So it's kind of cool. Kind of looks like a shark egg. That's weird. All right. right. If you want to do glass, go to glass. That's easy, right? Glass is right here. We have two options. Turn them on. Now we have glass.
Yay.
Okay, that's pretty easy. Glass is expensive. And when I say expensive, I'm talking about time for rendering. If you want to do, well, really anything that where the light transmits through an object or bounces off of the object to do a reflection, that is going to add to the cost of your render time. So that's a bargain you'll have to make. So if you want glass, just understand it may take a couple minutes extra per frame to render. Okay? So if you're ever sitting here wondering, why are all my frames taking like an hour each to render? Well, it may be because you're trying to make a crystalline ice sculpture, you know, princess tower castle from Frozen. That might hurt you. So, anyway, glass is pretty cool. I think it's pretty easy. You know, it does its job. You can change the roughness, again, kind of like with specularity. You have reflection colors or refraction colors. And then you can kind of change these to kind of mimic whatever you want. But I always will turn them both on, get it glassy, and then kind of mess with the settings to get it where I want it to be.
Now, with glass, if you just have a small cup, would it cost that much, or like, no?
No.
It'd just be okay?
Yeah. I mean, it just depends. Like, you'll see when you're doing the renders, you know, if you turn it to glass versus not glass, it may be, you know, 20 seconds a frame or something that may be added in. It really honestly depends on things like how close the camera is to the glass, what is transmitting through the glass, how much other stuff is in the scene. So, you know, it's not, you can do a cup. That's not a big deal. Now, if you have a MacBook Air from 2008,
Then,
It might light itself on fire.
please get a new computer.
It pulls from the CPU, right? Not the GPU.
Yes. Yeah, Renderman is a CPU renderer. They keep saying that there's options to go with GPU rendering, but I don't believe they've implemented that yet. So I'm actually really looking forward to that because that'll be like super nice.
Yeah. Well, would they be able to do like both, or is it just one or the other?
You know, I have a feeling it would just be one or the other. There's a lot of really interesting traction coming in from GPU rendering because it tends to, like nowadays, I think for a lot of people, your GPU, like it may be stronger than your CPU. And with the CUDA cores and everything in it, it may actually run through processes a little bit faster than the CPU. That's not always true for everyone, but that seems to be what their thought process is. And it may be cheaper to upgrade the GPU than the CPU for a lot of people. So you get better, you end up getting better performance per dollar that way. So anyway, yeah, I really hope they do implement that or something because that'd be just fantastic. Anyway, Glow. Glow is cool. It's not a light. It's kind of like a light. It does emit light properties, but it's not exactly a light. That's a really terrible explanation. But you have a gain. You can set your color. So if you need an object to glow, there you go.
So I guess that would be better than doing a light shape because then you would still be able to texture it, or
You could still add a texture to either one. So if you wanted like a floating, glowing Death Star, and you had like a texture for that, you could apply it to either one of those. So it'd be the color in here, or it could be the let's do the texture color in the object light. So you could do either one. But the object light is going to be a little bit more physically accurate, whereas the glow kind of just fakes it. So, I mean, it looks good either way, but yeah, it's not physically accurate with the lighting. Okie dokie. We do have other shaders. We have a Pixar Constant that I'll just go ahead and show you real quickly. The Constant, it looks like it's glowing. It's not. They don't actually glow. Pixar Constants are going to be essentially ignoring of any lighting information. So, like if I took this light right here, this directional light, and deleted it, it's still turned on, it's still white. That's because the constant just ignores lights in general. So even if like I take this light out, this object light, it's still there.
But if you render it, it's not growing.
Huh?
But if you render it out, it's not glowing or anything like that.
No, it just comes out as white.
Oh.
So this is really useful if you need to like do like quick masks. So like in After Effects, we can do track mats. And we can do like black and white images with like just this object by itself, and basically like track out a mat or a mask that we could like change color on. I use these for color correction. So like in the film I'm working on, I'm running into issues where, let's say a shader didn't pop in on my character's hairpin. Crap. Okay. It's easy. The color should be blue, but it comes out gray. So I can do a real quick like mask or a real quick constant like on our hairpin, turn everything black, turn the hairpin white, render it out, renders out like 1 second a frame. So I can get like a ton of frames done really quickly, drop that in After Effects, do a quick color correction, and now I have, you know, my blue or whatever color I need for the hairpin. So it's kind of an editing thing. It's a really quick fix.
Could you do like a chatter or a gumball thing? Like if you wanted a pattern on someone's shirt to just be a flat image that moves across, you could just mask it.
Yeah, absolutely. Yeah. All right. They do have a hair shader in here. I don't really use it too much, but if you did like hair, you could use that. The Pixar Disney shader does have uses, but I don't really use them. I like the surface shader more. But you can mess around with that. It has a lot of the same stuff in here. You still got your specularity. You have metallic if you need it. So you can mess with that. You have like base color, all that. You have a subsurface option if you want to add that in. So yeah, it's basically like a smaller version of the Pixar surface shader. Okay. What else? Volume. Okay, let's talk about volume. Let's make you into an object light. And then I'm going to take another sphere. So a volume shader, material, whatever you want to call it, essentially allows us to fill an object up with a volumetric material, like a gas, like fog. And so what it does is allows us to have light kind of catch on to particles in the air and create like the God rays you see coming out of like through windows or like out of the clouds after it rains. Like dust is hanging in the air. We can have like it kind of catching in there. So it's really, really useful for that. So what it is, went ahead and just made a sphere, and I put an object light inside of it. And so what I'm going to do is go ahead and apply a volumetric to it. And so I'm going to go ahead and go to the sphere with the cloud on it right here. Right click and do create Pixar volume. And you're going to see nothing. The reason why, let's do is because my volume is like super duper dense. It's like, where is it? Don't need that. Come back, sphere. There we go. All right, I just need a copy. Now you still have the object light on, right? Mesh light, yes, okay. Why are you not rendering? Oh, that one may have. Let's do. Are you gonna do it? Okay, sometimes the viewport renderer breaks. Okay, screw it. I don't really care. All right, let's do just preview renderer. We'll just look at it that way. There we go. That's what I'm looking for. So it looks pretty solid. The volume does, which is the big sphere. It feels like there's maybe like a little bit of subsurface going on because there's light entering the object and kind of moving around. But otherwise, it feels pretty thick, pretty solid. So if I go and start changing the density of this object, so I can go down to density float, which you can obviously change the color. Let's give me a color.
Yeah.
What would I had a blue, yellow, green. We'll just go with green. Blue, yellow, green. Okay. Okay, green. So the density float is going to change how dense that object is. So if I go to 0.5, you'll notice that light reaches through it a bit more. Okay. And if we go to a 0.25, you'll see it's going to drop a little bit more. So with a volumetric, depending on what you want to use it for, you may have to go to like absurdly low numbers in order to get it to do what you want. So let's do 0.1. That's not the absurdly low number, but we're going to get there. But now that we're 0.1, you'll start seeing that we can kind of see through the object a little bit. Okay? .01. You'll see that the object inside is emitting light, and now it's kind of catching and illuminating enough of the material to where we can see it on the outside. Now, if we had, let's say, let's do a window. I feel like if you ever like forget you have symmetry turned on and like you're not expecting it, it's kind of like the little helper that's like, hey buddy, I really want to help you like grab vases. Let's do stuff. All right there, buddy. Let's just calm down now.
Super excited.
All right. Let's get a more usable shape. So what I'm going to do is basically just have like light just kind of streaming through the window. And it's going to catch the volume. Okay, and let's take that density of fluid down to 0.01. The camera kind of close. And so you'll see that we have the light angle is being caught by the light outside with the volume being picked up. And then we go even further down, 0.001. It's kind of like a weird game of limbo. It's like, how low can you go? So you kind of start getting a bit of like an atmospheric build here. Maybe it feels like a little spooky or something like that. So it's really good for, you know, like fogs, mist, stuff like that. I'd like it quite a bit. One way that I was using it was in the film I'm finishing up. I had this cave, and inside the cave was this break at the ceiling. And so the morning light was kind of coming down through the cave, and it was kind of creating this shaft of light, and I really wanted that shaft to be illuminated. I wanted it to be visible in the shot. So I did a volumetric in there, and so the light would come down, catch it, and it just created this really beautiful effect. So it's got a good use. Any questions so far?
I like how when it's almost done, it goes like super speed and starts flashing.
Yeah.
Do you have that film that you can show us? Or?
It is so close to being done. I'm like within 50 frames of it being finished.
Was it the one in the gallery last semester?
Mhm. That was like only part of it. It's 14 or 12 minutes long.
Did it have lizard creatures?
Yes, it was a bird creature.
I knew
It was something. Yeah. No, it's really close.
The day you finish it, we just come and watch it?
Sure. Maybe. I don't know.
I would like it.
It's about 12 and a half minutes. Yeah. Yeah, it was actually a lot of students worked on it. So, yeah, I'm pretty excited to be done, so they can have a opportunity to get some credit. All right. Yeah, so that's volumetric. We went over went over the materials, went over the lights. So let's talk about render settings, because that is really important. All right, so Renderman, if you go under there, go to render settings. So right now, let's talk about image size. So HD, so right now it's set to HD 540. That's a really low resolution. Like that is like standard definition 1995 resolution. That is just, that's good. That's a really small, but it's a really quick image to look at. You'll see if we kind of blow it up a little bit, we can see that there's some graininess to it. It's not terribly high. There's not enough pixels really there. What I kind of consider standard is going to be 1920 by 1080, which is going to be getting into high definition images. I assume at some point they're going to be, doing 4K, 8K renderings, but you know, every size, every iteration you go up, you're going to be rendering, you know, millions of more pixels, which takes a lot longer to do. So when I'm kind of playing around with rendering and trying to get stuff out really quickly just to kind of look at it, usually I will stick with something that's like HD 540. But when I'm ready to move up and start rendering my work for like homework or something like that, that's when you move up to HD 1080, okay? So if I go in and render that out, you'll see that there is a pretty massive size difference just in the size of the image. So you'll see that's 540, and you'll see 1080. So it's basically 4 times the size, okay? But it's also going to take, you know, 4 times the amount of time because you have 4 times the pixels. So yeah, when you guys are kind of just playing around with stuff, you know, if you feel like if you did switch over to 1080, it's taking a long time to render it out, you know, don't just drop it down. Just go back to 540 until you get something you like, and then when you're ready to render it out for homework, then go ahead and jump up to 1080 and just go ahead and let it rip. So this is where you're going to see longer render times. Lower resolutions like 540, you know, are going to go really quick. But this, you know, this will take a little bit of time depending on what you're doing. It's not uncommon for you guys in this class to have render times that are between 5 to 20 minutes per frame. I've had students that have done projects where they have upped the settings in the rendering to where it may take an hour. If you have a Nintendo DS or a Switch, you may just whip that bad boy out and just, you know, play a game or two while you're waiting on it to finish. Yeah.
And I don't know if you're going to get this, maybe I asked, but what are the rules of like keeping the computer very slow for your renders?
So, are you talking about like just for the lab?
Yes.
Okay. Usually you're going to have free access like after Thursday 3:30. So if you want to set something up to render, you can just set it up, you know, after the afternoon class on Thursday. Computers are going to automatically reboot at some point Monday morning, so usually early Monday morning. So if you're batch rendering stuff, you have kind of like that chunk of time. If you have something that you're trying to render for like a longer period of time, I can't guarantee a student won't come in here if he needs to use the computer. He or she may just reboot it. So it'll happen. But
The ones down there are like just accidentally kicking them. Like the plug is right on the ground where I usually.
yeah, I'm not terribly happy about that.
Yeah.
Don't kick the plug.
I wasn't doing it on purpose.
Well, don't kick the plug, Tristan. All right. Anyway, usually if you're batch rendering anything, you'll like put a sign. Like I got pieces of paper up here that I usually will put up there that says like rendering, and you put your name on it. All right. So anyway, that'll take some time, but you will notice that with 4 times the pixels, that the image quality comes out quite a bit better. So it's just, you know, part of it. You just get a nicer quality image. But you also will see if we go under Renderman options right here, we do have things that say minimum samples, max samples, pixel variance. This is going to be numbers that you'll be changing to improve the quality of the image itself. So if you have noise in the image, if it feels grainy, even though you're rendering at 1920, it's, you know, you can go in and change these values to improve it. So let's say, just for speed's sake, let's go to 540. We already know what this looks like at 540. Okay. And let's go to max samples here. So this is going to be the maximum number of samples that Renderman is going to use when it's going in and examining every single pixel in the image. So you'll see like the little dots going across the screen. That's the sampling. It's just going to go through and check everything. The higher the number, so it's set to 128 now, the higher that number, the finer the image is going to get. It is going to go back and refine every single pixel and light sample depending on that number. I generally will keep this number part of, let's say, I don't know what the official name is, but 128, 512, 1024, things like that. So that kind of how the number like quadratically goes up. It's like factors of 2. So 128 is kind of considered like low end. Usually with my sampling, I'll go up to like 512 and go up beyond that. So if I bring the sampling down from max samples to like 32, that's going to give me a really, really fast render, but it's going to look like garbage. But it's fast. Like if you're wanting to like review something really quickly and you just need to get through it, then lower the sampling. See if it, see if it's doing what you want. So this was about a minute. And then this was 32 seconds. So it's the same resolution, but half the render time because I lowered my sampling by quite a bit. All right. But you will notice that if we look, well, it's maybe hard to see on the screen, but you'll see with a render or the sample of 128 versus 32, the grain is real. It's there for sure. So one of the things that we'll be grading your images on will be the image quality. So if you're turning in grainy images, that's going to affect your grades. You want to make sure that you're going to bring up that sampling accordingly. Now, depending on how high, you can just infinitely raise the max samples to whatever you want, but there's going to be a curve of the quality improvement versus the time it's going to take to render. And that curve is going to basically do this. So you can infinitely just add minutes onto your render, but if you're going to get like this much better in quality, is that really worth it? Probably not. Totally, yes.
I need that
Yes.
much better.
But see, if I go to 512, you'll see that it's checking the light samples, it's going through, and it's going to give you a less noisy image. You had a question over here? Someone? You?
Yeah. I was wondering, I think like I saw something on YouTube once, and it was like, to speed up like rendering time, sometimes I use this thing called a denoiser. Is that like a thing that Maya has?
Renderman does have a denoiser, yes. So it is, that's actually going to be in like batch rendering. So for like this project, we're not doing that, but we do have a denoiser in there. Basically, what that is it kind of like smooths out all the samples. So if you have like any areas that are like a little bit brighter than others, like any pixels that are a little bit brighter, it'll go through and like average them out. So depending on how low the sampling is, it could look really, really good, or it kind of looks like everyone just got blurred. So, but it definitely will help out with the speed, because that means you can go with a lower sample rate, but then the denoise will just be like a secondary filter. All right. All right, pixel variance. So this value is also something you can work with to help out with the noise. Basically, it's going to be a value that if you lower it, not to 0, but if you just lower it to like 0.001 or 0.0001, it's going to allow you to get maybe like finer black areas in the image. It's going to allow the sampler to kind of go in and like check things again. So that's another thing you can kind of mess with. Generally, I'm going to change the max samples first and then try to get it to where I want, and then I may fine tune with pixel variance. Okay. Minimum samples right here. So areas that Renderman does not think there needs to be any sampling done, so like deep shadow areas, it may not spend any time actually looking at. It's going to look at the brighter areas first where there's more detail, spend time kind of refining and rendering that area, and then it may spend a little bit of time with the deep black shadows. Minimum samples is a value that's going to be like, it's basically a clamp that says, no, we're not going to let you spend 0 time or 0 samples on the black areas. We want you to at least spend like 32 or 64. You can actually put in the value there to where it's going to go in and force Renderman to be like, hey, no, I need you to really look at some of these shadows because there is detail there that you're not getting before. All right. Your question about Denoiser. It's right here. It's under AOVs, Denoise. So if you go and click that, it'll add a post-processing effect where it'll actually will spit out like a secondary image when you batch render it, and that'll be like the denoised sample. Okay. When you render out your images, when you render it out here, basically when it's finished rendering, you can just save it. File, save, or export file. Save it out as a TIFF image. And then we can look at it from there. So that's going to be how you're going to save your stuff out for me. Okay? Okay. All right. So let's talk about your first assignment. So we don't have class on Monday. So generally I have people, Martin Luther King Day, in case you forgot. We'll come back to school for 1 day. Anyway, so I'm going to talk about this week's assignment since you guys will have a week on it. All right, if you look under the handouts folder in OneDrive, it's called Assignment 1, the game makes a parody. So this is essentially your introductory project to Renderman. I'm wanting you just to make one image for me. That's all I want, okay? You will be basically recreating a cinematic shot in Maya from a film. Doesn't matter what film, whatever you want, something that you feel is a really beautiful shot from that film, okay? But the thing is that you guys will be recreating it with not the characters from that film. So this is kind of where the parody comes in. So, like what I did for my example last semester, and actually if you look at the videos, you'll see like me going through that project, like actually I set up the whole thing on there. Was I had this character named Onimaru, who's in the film that I'm working on now. It's just this character rig. And you guys can use Onimaru. He's in the rigs folder, in the class folder. And I had him basically in the exact same stance as Harrison Ford in Raiders of the Lost Ark, when he is sitting there thinking about grabbing the statue, like the golden Buddha statue thing that's like sitting like right in front of him. Like he's sitting there like thinking about it. And so I had Onimaru sitting basically in a grocery store looking at 2 hot sauce bottles. Now the lighting's the same, the colors are similar. So what I want you to do is basically look at the lighting of the scene, recreate the lighting, recreate the camera angle, recreate poses for the scene, for the shot, but it does not have to be the same context. Okay? So if I had more time today, since we're kind of getting close to the end of the class, I was going to set up essentially that really iconic shot in Empire Strikes Back where Vader is like silhouetted all in black and Luke is silhouetted all in black and they're about to fight on Cloud City, but they have like this red and blue lights behind them and you just see their lightsabers, right? Like that's like a super iconic shot, right? I was just gonna have two little kids with their flashlights. So this is just, I'm not asking you to make any textures. I want you to use the shaders that we've talked about. I want you to work with the shaders, try to make stuff that looks interesting, play around with them. I've shown you the lights, so you can set up lights however you want, color them, do whatever you need to. You've seen light fog. I did not go over depth of field, but I will show you that real quick with the camera. But the idea is that, you're not making the image completely. It's going to be your own spin on it. All right? It should be fun. Part of it is when you guys turn it in, you're going to also turn in the actual shot from the film. So you're going to turn that in as a separate image file. So you can have two images that you're turning in. And we're going to kind of play a game of like, we'll look up at the image that you made, and then we'll try to figure out which film that came from. It's going to be easier for like more well-known films. Like last semester, someone turned in a film from like no one had ever heard of. We had no clue what she was doing, so it was kind of weird, but it's still fun. It's a fun project. All right, so let me show you some of the examples, because you're probably like, what the hell is he talking about? Let me just, okay, there it is. So Cameron, she was in the class last semester. She did this shot from Inception. So that was what she did. It was like a beer pong game that she set up with the lighting and everything that was like supposed to match. This image sucks. Let me just download the whole folder. But she was doing a shot from Inception where they were sitting around like kind of like a boardroom table and talking. So that's the original image that she was going for. Oh, don't you do this to me. Oh, I swear, I hate this. Okay, come on, open. Sign in. I'm gonna have to call up IT about this. Like, this happens like every semester. All right. Alright, screw it. It's going to be dark, but this is just the color space it was made in. But you get an idea of what she made. Character, it's switching over because it's like a weird color space, so it should show it properly at Photoshop. But anyway, so she did basically the same pose, but just a different context. And so the humor of this is that it was a beer pong game. Hannah did Jurassic Park. So super iconic image. Alan Grant tempting the Tyrannosaurus Rex. And then she did that with a chicken.
So can we use like any models you can find, or?
Yep.
Okay.
Yep. Tiffany did that shot from The Matrix, where Neo is really interested in the caliber of bullets that are being fired at him. And she used my Onimaru rig, and he's playing Jenga. But they're mimicking the lighting, mimicking the camera angle of the original shot, just recontextualizing it. All right? Okay. Now, in terms of set pieces, environments, stuff like that, you can really make whatever you want, use whatever you want. In terms of characters, you can use the character rigs that I have dropped into our folder. So these are character rigs that either I've made or found. They're pretty simple to use and pose. I mean, you're just going to be posing them anyways. You can get whatever you want offline. Highend3d.com is a really good resource for getting character rigs if you want something like really specific that I just don't have.
High-end 3D.
Highend3d used to be called Creative Crash. TF3DM is good for models. They do a lot of free models on there. CG, what is it? CG Trader may have some free stuff on there. And Turbo Squid.
Triple split.
Turbo Squid.
Turbo Squid.
Turbo Squid. So that's a good resource as well to look at. Yeah.
Is that what we got?
What was the one you said you were now?
CG Trader, a lot of it's going to be like paid stuff. It's like where a lot of people put like models and stuff up that they've made and they'll try to sell. But there might be some free things up there as well.
And the one you said before that? You remember?
High-end 3D, TF3DM, Turbo Squid, CG Trader. Actually, you know what? Thingiverse, the 3D printing model website, actually has a lot of good stuff too. It's all made for 3D printing, but I mean, if you just need a model, you're gonna like throw a color on. Might not be bad to do.
Add some bones if necessary.
Huh?
To add some bones if necessary. If you, like, do the 3D modeling ones actually have like posable bones?
No.
Yeah, so I'm sorry, add some bones if necessary.
Yeah, sure. Just add bones.
Yeah, there's a Linda tutorial for that, right?
I mean, we have an entire half a semester on that in advanced animation, but yeah, sure. Just sure. How many of you have never touched a character rig before? Okay, so you're probably like, oh god, how do you use a character rig? Let me just open one up real quick and I'll show you kind of like how my stuff works. It's not the same for all rigs, they're a little bit different, but yeah, I'll show you mine. Squid finished. Yeah, squid finish rig. Huh?
Squidward.
Nope, squid finished. Oh, I do have a Squidward, yeah. We did do that last semester. That's in the folder. All right, so this guy. This was a project from last semester for students. If you're in the advanced class this semester, you guys will work on this as well. So most rigs are going to have what's called like a world controller that you can kind of move the entire character around with. Depending on what the character looks like, the world controller is going to be in different places, but you can just grab it and move it around. You can, when you're moving a character rig around, make sure you grab the little shapes that are around the body. These are called controllers. You can move them around, rotate. Usually ones like arms and legs, you're going to want to rotate them as really more than like translating them, kind of rotating it at their joints, like where they would bend, like elbows, shoulders, knees, hips. Some of the characters may be a little bit stretchy, so like this guy is a little stretchy. And then depending on the character, you may have, where did I put? You may have a set-driven key that you can use to do certain things like blink eyes, open mouths. So on this guy, you can open and close the beak. If you go to the channel box and click on his root controller, which is this cog right here, and you have one that's called beak open close. And if you middle mouse drag that, you can see that he'll open and close his mouth. It's going to be different for all the rigs, just because they were all just made for different purposes. But that's really basically just how you kind of work with them and mess with them. Okay? So try not to tear them up.
What's
Yeah.
the floating ball in the background? Is that just
So the way that I think I have a rendered image. There it is. So basically, it's like other eyes kind of floating in the background, like more squids are like ready to get you. So anyway, any questions about the assignment? Yes, sir.
Do you want us to stick with mainly like real life movies, or?
So that's a really good question. Let's say yeah. Let's go with live action movies, and here's the reason why. I want you to look at physical lighting. So with cartoons like anime, they don't do physical lighting at all. So let's go with just live action stuff. So you can look at it, kind of examine it, like with like your face right now, you have basically two light sources. One is coming off, bouncing off this screen, and then like another one's coming through the windows. So you can kind of like look at that image and figure out like where you need to put your lights in your scene based on the reference you're looking at. Okay, so let's just stick with live action. Sound good? Okay. That crush anyone's dreams? No? Slightly? Okay. Any other questions? Yes.